All right, folks, Best Action is back in action here. We are going to do a quick review on this page of functions and how to determine if a relation is a function. So the first thing that I want to call your attention to are these definitions that I have here at the top. You'll notice that I've already written them in. You may want to pause the video and write these definitions down. So the first one is a relation, and we define that as a correspondence between two sets. A function is going to be a relation that associates each element of x to exactly one element of y. Now, those definitions might seem a little bit complicated and a little bit mathy for you, but we're going to break those down, and I think that they really will make sense to you. So the first thing to notice is that functions are relations. So if we want to think of this in terms of a Venn diagram, we can think of all of the sets that would be relations. And then what we can think about is that within that world of relations, we have some of them that are considered functions. So some of our functions are relations, but not all of our relations will be functions. Now, there are three different ways that we can determine whether or not our particular relation is one of those special items called a function. So first of all, we can look at it graphically. Now, this is typically our easiest one to analyze, because if we're going to look at it graphically, most of you guys remember this, we are going to use the vertical line test. And I know you guys will probably remember that. So we're going to use our vertical line test. And remember, this is often abbreviated the VLT. So our vertical line test tells us that we just draw in, imagine vertical lines coming down through our graph. And if at any point we draw in a vertical line and it intersects the graph in more than one place, we say that it fails the vertical line test. So you can see on this first one that no, this is not going to be a function because it fails our vertical line test. If we move on to the next one and we check that again, we're just going to imagine these vertical lines, every possible vertical line that could be drawn in. We can see our next one will be yes. Okay? Because graphically we can see that it passes our vertical line test. On the next one, the one thing that I do first want to draw your attention to is that if I give you a graph that goes all the way to the edge, I want you to go ahead and fill in some arrows here on the end. The program that we create this with won't put those arrows on the ends, but if it hits the edge, it goes forever. Now, this one again, if we just picture those vertical lines being drawn in there, we can see that, yes, this one does pass our vertical line test as well. All right, so that's all you have to do if I give you a graph to test whether or not a relation is a function, is just check that vertical line test. Now, if I give you a mapping, mappings are going to be a little bit different. When we work with our mappings, what we're going to look for, and this is not really a technical way to say it, this is the way I always think of it, is we're going to make sure that no input, okay, we can think of that as our left-hand side or our x's, so that no input is split. I'll talk about what that means, is split to two outputs. So, for example, if I look at Jim, I can see that Jim only points to that score, Joseph only points to that score, Emma only points to that score, and Greg only points to that score. So on this first one here, this first mapping, we would say yes. There are no splits. Moving on, if I look at the next one, I say that Jim goes to pre-calc and Mary goes to physics and Joseph goes to pre-calc and Emma goes to foods and Greg goes to foods and Bob goes to physics and Tim goes to English. So again, there are no splits. So yes, no splits again. So this one looks good. But when we get over here to our last one, we can see that Jim is pointing to the fish and Jim is pointing to the dog. That's our problem here. So this is what I refer to as a split. I've got Jim splitting to two different things, and that's not allowed. So we're going to say no, because we can see that Jim is assigned two outputs. And that's our problem. Now, the next thing that we're going to look at, our last one that we're going to look at, is if these values are given to us in the form of ordered pairs. So for our ordered pairs, we're going to look for duplicated x values. Now, why are the duplicated x values the problem? Because if we graph the same x value with two different y values, what we can think about is that we would end up with this scenario that we have up here at the top. If I have a single x value, for example, of 2, but I have two different y values, it's going to fail the vertical line test. So down here, if we're given ordered pairs, we just have to look for anywhere that we would have duplicated x values. So I see that I've got my 1, and I see that I have 1 in two different places on this. So I've got this one, and I have this one, and that's two different y values that I'm getting. So this is going to be a no. If I plotted that, it would fail the vertical line test. So we can see that 1 is assigned two outputs. If we check our next ones, we can see that there are no repeated 5s. I can look at all these x values and none of them are repeated. So we would say yes. And if I look to my last one, I look at all my x values and I see that none of those have been repeated either. So this would also be a yes. So you need to be comfortable with all three ways to determine whether or not a relation is a function.